Yeah, this inverse trigonometric functions. So what the important thing to be remembered with regards to this inverse trigonometric functions is that you cannot take all the trigonometric functions directly to write the inverse. That is a main point to be remembered, and it is to be understood that a function will have inverse or the inverse exists to a function only when it is a bijection. Very, very important thing to be remembered. Based on that only, this one, the inverse is defined. I'll tell you like this. Very simple thing. Everyone will understand this. And if you understand this, you will be knowing why these many restrictions are imposed in defining inverse trigonometric functions. For example, if I take a function like this, a, b, c, d, and I have taken 1, 2, 3, 4, 5, and I'm making it a let me share the screen. Yeah, what I'm saying, if I'm taking a 1-1 function, why not inverse is possible? Let me brief it and let me revise it so that you'll have more clarity about the inverse. Let me map it like this. It is a 1-1 function, Now, for this 1-1 function, if you want to write the inverse is not possible because in this case, one will not have, the image if you write the inverse. So only for 1-1 function, I repeat, only for 1-1 function, inverse is not possible. Similarly, if you take an onto function, like this, a, b, c, d, and let me say 1, 2, and a is mapping to 2, b is mapping to 1, and c is mapping to 2, d is mapping to 1.
Not a function.
Huh. So if you write the inverse, what happens in this case? In this case, you will have two images. You will have two images for 1, two images for 2, which will not make it a function. And similarly here also, 1 will not have image and hence it will not become a function. So taken 1-1 as it is, inverse not defined. Taken onto as it is, inverse is not possible. So what the mathematician formalized, he said that the function should be a 1-1 or 2 function. It is common sense that you too can understand. If you take a function which is a bijection, a, b, c, d, 1, 2, 3, 4, what happens if you map a to 3, for example, b to 1, and c to 2, and d to 4, on both sides the function is defined. So very, very important thing to be remembered with regards to the inverse of a function is that f maps a to b, implies f inverse maps b to a is possible only when f is a bijection. This is a most important thing and the fundamental thing to be remembered with regards to inverse trigonometric functions. So unless a function is a bijection, you cannot even talk about the inverse of a function. You cannot even talk about the inverse of a function. So now, because here ABCD are mapping to 1, 2, 3, 4, and 1, 2, 3 will be mapping to ABCD, and both sides it is defined as a function, and hence a function to have inverse, it must be a bijection. Very important thing, please. Very important thing. It must be a bijection. Now, coming to trigonometric functions, let us understand. Coming to trigonometric functions, what happens? If you take a trigonometric function, for example, first beginning with I'm taking a sine function. If you take a sine function, let me take an example that if you take 30 degrees, and if you take 150 degrees, if you take 390 degrees, and so on, and if I take 1 by 2 here in the codomain, then what happens? 30 degrees will map to 1 by 2, 150 will map to 1 by 2, 390 will map to 1 by 2. Is it a 1-1 function? Respond, please. I asked you a question. Is it a 1-1 function? No. No. It's not a 1-1 function, because many values or many angles are mapping to 1 by 2 only. Because here f is equal to sine. So, but mathematician wants to define the inverse of the trigonometric function, and hence he verified in which interval this is behaving as a 1-1 function. In which interval it is behaving as a 1-1 function. So, for that he observed that between minus 90 plus 90, it behaves as a 1-1 function. So a 1-1 and as well onto minus 90. I'm taking example minus 60, minus 45, minus 30, 0, 30, and 45. The known values I'm taking 60, 90, like this. Then he observed that in this interval it is behaving as a 1-1 function and as well a bijection. It is behaving as a 1-1 function and as well a bijection. Like how? For example, if you write all the values of sine for these angles, if you write all the values, it will be like this. That is, for this one, you will have minus 1, minus root 3 by 2, minus 1 by root 2, and minus 1 by 2, 0, 1 by 2, 1 by root 2, root 3 by 2, 1. So, if you map them, what happens? Different elements will have different images, and all the elements, all the elements in the codomain will have one pre-image, and hence it is 1, 1 and on 2. Understand that it is 1, 1 and on 2, which is a bijection. So what mathematician planned here? Let us define the inverse for sine in this interval only, because in this interval only it is behaving as a bijection. It is behaving as a bijection. So what he did, just it's clear, everyone. Please see this one. Taken as it is, I'll tell you in this way. Taken as it is, if you take sine function, sine taken as it is, it accepts every real number, and it yields the values between minus 1 and plus 1. Okay, so it's not a bijection.
Yes, sir.
It's not a bijection, but if you see this bar, so what he did, mathematician, what he did, he restricted the domain of it. He restricted the domain of it between minus pi by 2 and plus pi by 2 to minus 1 comma plus 1, and then he defined inverse of it. He defined inverse of it like what? Then if you write the inverse of it, it will be sine inverse of minus 1 to 1 to minus pi by 2 to plus pi by 2. Very, very important and basic thing, fundamental thing that is to be remembered in inverse trigonometric functions is that taken as it is, no trigonometric function, taken as it is, no trigonometric function has inverse, but it is defined, the inverse is defined by restricting the domain of the trigonometric function. This is the basic thing to be understood, and without this you cannot follow why these many things are happening here. Domain is restricted like this, minus pi by 2 plus pi by 2. So then only inverse of the trigonometric function is defined. This is about sine I discussed. Okay. Now, what is a basic thing to be understood? If I ask you a question like this, sine inverse of sine 2 pi by 3, if I ask you, if someone is saying 2 pi by 3, understand that he doesn't have the basic knowledge of inverse trigonometric functions, which is wrong. Which is wrong. Why? Which is wrong. Why? It is not belonging to. It is not belonging to minus pi by 2 to plus pi by 2. So, whenever you come across this type of problems, don't straight away write 2 pi by 3, please, and adjust them. Adjust the value in between minus pi by 2 plus pi by 2. Then only you can.
Pi plus
then only.
minus pi by 3
then only you can define it. For example, if you take the same problem, sine 2 pi by 3 can be written as pi minus pi by 3, then it can be now written as sine inverse of sine pi by 3. Now this is pi by 3 is the answer, which belongs to minus pi by 2 to plus pi by 2. Important thing to be remembered, please. So this is the basic and fundamental thing you have to understand with regards to the inverse trigonometric function. So let me show the domains and ranges of different inverse trigonometric functions faster, and you remember that, memorize them, because without this you cannot further solve the problems. This plays a major role. What I say, this plays a major role throughout the inverse trigonometric functions. Okay, so let me write that. That is, first function what I'm taking is sine inverse. Just a moment, please. You might be knowing that, but I must explain you this in my style. That is the reason why I'm taking it up, because I want to tell you the importance and the role they play. What are they? Domain and range in solving the problems of inverse is very, very important. It's very, very important. That's the reason why. That's the reason why you must have clear idea about the domains and ranges of different inverse trigonometric functions. Number one, y is equal to sine inverse x. This is nothing but x. This is nothing but 1. Don't forget. The input is minus pi by 2. Just a moment. Just a moment. I wrote wrong.
minus 1
Minus 1 to
to 1.
1 because sine range is minus 1 to 1 and that will become domain of inverse. And here, this is the point to be remembered. Taken as it is not a bijection. That is why mathematician restricted its range to this one. Okay. Similarly, if you come to cos inverse x, same, minus 1 to plus 1. And it is 0 to pi. Number 3, y is equal to tan inverse x. It is set of real numbers, the domain. But it is open minus pi by 2 plus pi by 2 open. It is just like sine inverse x only. But only thing is it opens. It is closed interval, it is open interval. Similarly, if you take y is equal to cot inverse x, it is set of real numbers, no doubt, and it is just like cos inverse x only, but interval is open. Next is secant inverse x, and it is the reciprocal of cos x is secant x, and cos x lies between minus 1 plus 1, and secant x never lie between minus 1 plus 1. It is taken as it is r minus of minus 1 to r, and it is just like cos inverse x only.
minus 0 1.
It is just like cos inverse x only, 0 to pi only, but it won't take pi by 2. The reason is 1 by secant pi by 2. Secant pi by 2 is 1 by cos pi by 2. 1 by cos pi by 2 means 1 by 0, not defined. That is why that value is deducted or subtracted. Similarly, y is equal to cosecant inverse x. For this also, it is same. Cosecant x is reciprocal of sin x. Sin x lies between minus 1 plus 1 and its reciprocal never lie between minus 1 plus 1. So similarly, it is a case with inverse also, or minus of minus 1 to 1. It is just like sine inverse x only. Minus pi by 2 plus pi by 2. But it won't take 0. The reason is cosecant 0 not defined. Cosecant 0 not defined. So, what is that? I'd like to highlight the points here just for you to remember easily. The domains of sine inverse x, cos inverse x are same. Boys and girls, domains of sine inverse x and cos inverse x are same. And domains of tan inverse x and cot inverse x are same. Just see.
Yes, sir.
Domains of this one, secant inverse x and cosecant inverse x are same. Just observe this. Same. Okay. So these are allied angles. Sine, cos, allied. Tan, cot, allied angles. Secant, cosecant, allied angles. Their domains are same. And similarly, here also, this is important thing. Range is important thing here. Range is important thing here. What is that? Let me tell you. This one, if you observe carefully, minus pi by 2 sine inverse x, tan inverse x minus pi by 2 plus pi by 2, and even cosecant inverse x also minus pi by 2 plus pi by 2. With closed interval here, accepts every value. It is open interval here, minus pi by 2 plus pi by 2 not accepted. It is closed interval, 0 only not accepted. So all the three you can take them as same. What are they? Sine inverse x, tan inverse x, and cosecant inverse x. Okay. Now coming to cos inverse x. Just observe it. Close 0 to pi. Cot inverse x. Open 0 to pi. Secant inverse x. Open 0 to pi minus pi by 2. You understand this similarity. Then you need not have to by heart anything. Just observe that the reason also, the denominator of tan x is cos x, and this is sine inverse x. Similarly, cot x, if you take cot x, the denominator is sine x. So, if you observe the trigonometric functions values, domains and ranges, you will understand them very easily. So this is what the conclusion about the domains and ranges of inverse trigonometric function. This is the reason why. This is the reason why you will have many more restrictions. You will have many more restrictions with regards to the formulae that are there in inverse trigonometric functions. It is only the reason. It is only the reason because the range, if you write sine inverse x value below minus pi by 2, above pi by 2, take it as granted, you don't have the basic knowledge of inverse trigonometric functions. If you write the value of cot inverse x below 0, above pi, and or equal to 0 or equal to pi, take it as granted you don't have the basic knowledge of inverse trigonometric functions. So whatever the range or whatever the value you write about the inverse trigonometric functions, you must keep these in mind before writing them. Please take a screenshot of it. It is very, very important thing to be remembered with inverse trigonometric functions. I think you have inverse trigonometric functions in your 12th board also, isn't it? Sleeping, everyone in the class?
No, sir.
What I said, you have this inverse trigonometric function. Do you have inverse trigonometric functions in 12th board?
Yes, sir.
You have that in your board exam. You must thoroughly learn it. Priyanshi.
Yes, sir.
You must thoroughly learn it because you have the same topic in your board exam. Okay, so take a screenshot of it and save it. This becomes the reference point for any formula what we learn further. Okay, now let me move on to the formulae of all the inverse trigonometric functions. Okay, let me revise at pace. Let me revise this. So this is all I explained. The ranges and domains. Just see how the graph of sine inverse x is. And I'll show you like this. This is drawn between -1 and +1. If you take sine x graph, no, sine x graph, it will go like this. If you take sine x graph, like this it goes. But understand, please. Understand, please. Any function and its inverse or mirror images in the line y is equal to x. Very, very important thing and conceptually you must understand that. Y is equal to x is the line which behaves as the mirror to a function and its inverse. Which behaves as a mirror and functions to function to the inverse of the function. So whatever the function you take now, whatever the function you take now, if you know the graph of that particular function, if you know the graph of that particular function, for example, that function is like this, let me say. Okay, then if you want the graph of its inverse, very, very simple thing to be understood is that if you take the mirror image of this function in the line y is equal to x, that will be the mirror image. That is, this goes like this. It's mirror image. It will go like this. It will go like this. Like this it will. So, if it is y is equal to fx, you know, it is y is equal to f inverse x. Remember that. So, this is in the advanced level problems, you must have this idea very clearly, very clearly. Any function, if you know the graph of that particular function, its inverse graph will be the mirror image of this graph in the line y is equal to x and vice versa. Okay. How many are there in the class? 25. That's it? No. That's what I have discussed. Now let us proceed to the domains and ranges. I have already given them as table. Just observe. This is cos inverse x graph. Anyone in the class? Do you tell me sine inverse x graph is increasing or decreasing function? Respond.
It's increasing from 0 to pi by 2, then from pi by 2 to pi decreasing.
Which one, beta?
Sine inverse of x.
अरे यार क्यों यार x तो बढ़ रहा है तो y भी बढ़ रहा है ना यार.
हाँ.
तो इंक्रीजिंग है. और cos inverse x के बारे में बता. It is decreasing. धनंजय.
Yes sir, it is decreasing.
अरे यार कभी इंक्रीजिंग वाला कैसा रहेगा? x बढ़ रहा है तो y भी बढ़ेगा ना. वो तेरा पेट का नीचे भाग है, वो ऐसा रहेगा. तेरा पेट है ना, ऐसा नीचे भाग है, ये इंक्रीजिंग है. तेरा पेट का ऊपर भाग है ना, वो तो डिक्रीजिंग है. ऐसा x बढ़ेगा y घटेगा, ऐसा. ठीक है ना. सो cos इनवर्स x इज पेट बढ़ गया ना रे. इसमें क्या वो कोरोना का लॉकडाउन में पेट बढ़ गया ना तेरा, ऐसा तो पेट है धनंजय.
नहीं सर.
नहीं बढ़ा तो कुछ एक्सरसाइज कर रहा है तो.
हाँ सर.
झूठ बोल रहा है रे. सोने वाला एक्सरसाइज क्या करेगा? क्लास में ही सो जाता है तो. मैं आई विल नॉट बिलीव दैट. ठीक है. सी नाउ दिस वन, इफ यू see the graph of tan inverse x. Just visualize and remember them. Visualize and remember them. What I'm showing you, the graph of sine inverse x first, and this one graph of cos inverse x. Okay, next see the graph of tan inverse x. See this one, how this is. It lies between minus pi by 2 plus pi by 2, open interval, but it extends throughout x-axis. Set of real numbers. Throughout x-axis it extends. That means its domain is set of real numbers and range is minus pi by 2 to plus pi by 2, open interval. Similarly, just see cot inverse x. You can see just it is उल्टा लग रहा है ना ये tan inverse x and cot inverse x का. ये तो minus pi by 2 plus pi by 2 है तो 0 to pi लगेगा ये cot inverse x. ठीक है. ये दोनों देखो. secant inverse x का ये देखो, कभी -1 +1 के बीच में ना रहेगा। ऐसा ही ट्रिग्नोमेट्रिक फंक्शन का भी ऐसा ही है, कभी देखो आप -1 +1 के बीच में ना रहेगा। Okay, that is about secant inverse x, and similarly cosecant inverse x also. कभी देखो ये -1 +1 के बीच में ना रहेगा। उधर ऐसा आएगा, किसमें? ट्रिग्नोमेट्रिक फंक्शंस में ऐसा आएगा। ऐसा है तो अगर secant inverse x का ले लिया तो आपको वो ग्राफ कैसा रहेगा? Just for example sake, I'm showing you that this is -π/2 to +π/2 position, and secant 0, as you know, is secant 0, as you know, it is 1. So what happens, you know, you will have the graph like this. This is 1. The graph will be like this for secant x. दूसरा इधर -1 से नीचे रहेगा। हाँ, वही बोल रहा हूं बेटा, मैं क्या बोल रहा हूं, अभी ये secant inverse x का ग्राफ में ये y एक्सिस पे -1 +1 के बीच में ना रहेगा। y एक्सिस में -1 +1 के बीच में ना रहेगा, वो ही x को शिफ्ट हो जाता है इधर, क्योंकि secant inverse x नेवर secant x क्या बेटा does not belong to secant x does not belong to -1 to +1. secant x मतलब y वैल्यू है, y वैल्यू कभी -1 +1 के बीच में नहीं रहेगा। इनवर्स में क्या हो जाता है, ये x वैल्यू -1 +1 के बीच में ना रहेगा। So it is totally, they're all simple thing, I'll tell you.
ग्राफ का उधर नहीं आएगा ना सेकंड को,
क्योंकि इधर भी रेंज रेस्ट्रिक्टेड है ना, डोमेन का रेस्ट्रिक्ट करके इनवर्स डिफाइन करता है, डोमेन को रेस्ट्रिक्ट करके इनवर्स डिफाइन करता है। दैट इज द रीजन व्हाई पार्ट ऑफ इट ओनली शोन हियर जस्ट फॉर अंडरस्टैंडिंग से।
आपके ग्राफ में वो ऊपर वाला ग्राफ ये साइड आएगा ना, एक्सिस पे नहीं।
हाँ वो गलत है, वो गलत है, एक मिनट
अपना डुअल वैल्यूज आ
नहीं ये नहीं,
नीचे का ग्राफ,
हाँ मतलब नीचे का ग्राफ।
you're right, ऐसा आएगा है ना।
यस
ठीक है, this is what I have given you the table. Now, very importantly, this one you will come across frequently. Sine inverse of sine theta is equal to theta only when theta lies between -π/2 +π/2. Don't forget that. You can write as theta only when it lies between -π/2 +π/2. Otherwise, it changes. Similarly, cos inverse cos theta is equal to theta. You must know that the theta lies between 0 and pi. Otherwise, not. Similarly, tan inverse of tan theta is equal to theta only when theta lies between -π/2 +π/2. Remember, please. Similarly, cot inverse of cot theta is equal to theta only when you know that theta lies between 0 and pi. You can write secant inverse of secant theta is equal to theta only when theta lies between 0 to pi. Of course, pi/2 deleted. Similarly, cosecant inverse of cosecant theta is equal to theta provided this is theta lies between -90 +90 and or 0 to -90 to 0. Of course, 0 eliminated. Then what happens? This is an important point to be discussed, particularly in inverse trigonometric functions. Then, sir, as you are saying sine inverse of sine theta is equal to theta only when theta lies between minus 90 plus 90. If theta is not lying between minus 90 plus 90, what is to be done? You have to make the theta to adjust between minus 90 and plus 90. Then only you can write the result. Otherwise not. Otherwise not. Which is, I have opened the graphs for it. Let us see that. This is an important point to be discussed. See this one. ये क्या है? Graphs of arc sine of sine x and sine x over 3 periods. Good. That's given nicely. अरे सबको ये स्क्रीन दिख रहा है ना बेटा? मैं क्या बोल रहा था बेटा? इधर आपको एक मिनट बढ़ा दिया साइज को. ये क्या है? आर्क साइन ऑफ साइन एक्स बेटा. Don't get confused with arc. Arc is nothing but inverse. Arc is nothing but inverse, please. Arc sine of sine inverse sine x means it is nothing but sine inverse of sine x. Okay. Now follow this carefully, please. What is the restriction here? Whatever you do, but see that sine inverse x value lies between minus 90 plus 90. That means always you have to make yourself sure that the value of sine inverse x lies between these two values. This is above limit is 90. Above limit is 90 and below limit is minus 90, please. Above limit is, I'll write below limit first. Below limit is minus pi by 2 and above limit is plus pi by 2. Don't forget. Then you write whatever the value you like. So what the mathematician did, he modified the values like this. See carefully, please. Between minus pi by 2 plus pi by 2. I'm talking about this. So first of all, the basic thing to be understood, whatever the sine inverse x value you write, they must lie between minus pi by 2 plus pi by 2. Okay? Remember that first. Okay. Now, between minus pi by 2 plus pi by 2, what is that happening? Between minus pi by 2 plus pi by 2, what is that happening? You can have y is equal to x directly. What is it? Let me show. This is y is equal to x. That means if something like sine inverse of sine pi by 3 is there, close your eyes and write pi by 3 directly. Because it is lying between minus 90 plus 90. Okay. Now, here, just observe this carefully. What is that happening between pi by 2 and 3 pi by 2? This is the important point to be noted. Between pi by 2 and 3 pi by 2, you cannot take y is equal to x here. Y is equal to x means this is x. Okay, you cannot take, but you have to make it. What is the value I have chosen here? Pi by 2 to 3 pi by 2. Just to say this. Pi by 2 less than x less than 3 pi by 2. Then how to write this? Y is equal to
minus x plus 5.
ये कौन है? श्रीवर्धन है.
Yes, sir.
क्या हो गया बेटा? इतने दिन नहीं आया क्लास में. So what happens, it is properly not drawn here. The angle between them will be 90 degrees, please, because it takes a turn 90 degrees. So this line will be perpendicular to y is equal to x, and don't forget that it will be in the form of y is equal to minus x because it is perpendicular to it. And it passes through which point? Pi comma 0. It passes through which point? Pi comma 0. Substitute pi comma 0 here. So 0, y is equal to minus x plus c. It is in the form of y is equal to minus x plus c. See this graph better than this. I have drawn nicely. Let me show you that. Just a moment. Just a moment, please. Yeah. Yes. Just a moment. Yeah. This one. This is I drawn for, I think, y is equal to sine. This is a different one. What about this? Tan x. Yeah. Just a moment, please. Just a moment. Yeah. This one. See बेटा, सब लोग ध्यान से एक बार देख लो. ये तो इम्पोर्टेंट है एडवांस लर्निंग के लिए. एडवांस लर्निंग के लिए एक ग्राफ का बहुत इस्तेमाल करना पड़ता है. तो मैं क्या किया, इधर y x का वैल्यू माइनस पाई बाई टू प्लस पाई बाई टू के बीच में रहा, तो माइनस पाई बाई टू प्लस पाई बाई टू के बीच में रहा, तो मैं क्या किया, इधर आप देख सकते हैं माइनस पाई बाई टू प्लस पाई बाई टू के बीच में रहा, तो मैं क्या किया, y इज इक्वल टू x लिख दिया डायरेक्टली. y इज इक्वल टू x लिख दिया डायरेक्टली. मतलब क्या है, जो वैल्यू अंदर रहेगा वो वैल्यू डायरेक्टली लिख दो, कुछ भी सोचने की जरूरत नहीं. मतलब क्या है, साइन इनवर्स ऑफ साइन 30 डिग्रीज है तो 30 डिग्रीज डायरेक्टली लिख दो. साइन इनवर्स ऑफ साइन 60 डिग्रीज है तो 60 डिग्रीज लिख दो. साइन इनवर्स ऑफ साइन 90 डिग्रीज है तो 90 डिग्रीज लिख दो, कुछ भी प्रॉब्लम नहीं है. लेकिन साइन इनवर्स ऑफ साइन 120 है तो डायरेक्टली नहीं लिखना है. क्यों? इधर रेस्ट्रिक्शन क्या है, ये माइनस पाई बाई टू प्लस पाई बाई टू के बीच में रहना चाहिए. मतलब एक ग्राफ तो ऊपर जाएगा नहीं, ऐसा एक ग्राफ तो ऊपर ऐसा जाएगा नहीं, क्योंकि ये तो नीचे आना ही पड़ेगा, और नीचे का रेस्ट्रिक्शन है माइनस पाई बाई टू, तो पूरा का पूरा ग्राफ माइनस पाई बाई टू प्लस पाई बाई टू के बीच में रहना चाहिए. The graph must lie between minus pi by 2 plus pi by 2 only. So it fluctuates between minus pi by 2 plus pi by 2. Now the important thing to be observed that this is y is equal to x is the line, and this line will be perpendicular to it, and hence it will be in the form of y is equal to minus x plus k. Just observe this carefully. You need to by heart also if you understand this. Y is equal to minus x plus k, but it passes through which point? Respond please, anyone. It passes through which point, please? Pi. So pi comma 0. So 0 is equal to minus pi plus k. So what is k here? Pi. So replace this here. So that will become y is equal to pi minus x. So in between the interval pi by 2 to 3 pi by 2, in between the interval pi by 2 to 3 pi by 2, y is pi minus x. Y is pi minus x. Remember that, please. Remember that. So I'm taking an example like this. Sine inverse of sine ऐसा ले रहा हूँ 5 pi by 6 लिया बेटा. 5 pi by 6 150 है. ओ इसको साइन इनवर्स ऑफ साइन 5 pi by 6 को 5 pi by 6 नहीं लिख सकते, क्योंकि वो माइनस पाई बाई टू प्लस पाई बाई टू के बीच में नहीं है. तो इसको हम अभी ऐसा लिख सकते हैं, pi minus 5 pi by 6 लिख सकते हैं. That's what I said. So it is nothing but pi by 6. Remember that. It is nothing but pi by 6. Similarly, in the next part of it, what happens? In the next part of it, what happens? In the next part of it, 3 pi by 2 to 5 pi by 2, that must adjust between again minus pi by 2 plus pi by 2 only, and it will become parallel to y is equal to x. Just to see that. It will become parallel to y is equal to x, and hence it will be in the form of y is equal to x plus k, but it passes through which point? Respond?
2 pi comma 0.
So write that 2 pi plus k, your k will be minus 2 pi, so your y will be x minus 2 pi. That's what I wrote. This is a thing to be understood. Now, for example, if you are given a sine inverse of sine, for example, 300 degrees is given. 300 is how much? 300 means 30 into 10, 3 pi by 6 into 10, 5 pi by 3, for example. I wrote this. You should not write it as 5 pi by 3, please. You should not write it as 5 pi by 3. Just observe where it is lying. It is lying between 3 pi by 2 and 5 pi by 2. 300 lies between 270 and 540. 270 and 540. 450. 270 and 450. And hence it will be x minus 2 pi. So it will be 5 pi by 3 minus 2 pi. So the answer is not 5 pi by 3, but it is minus pi by 3. Very, very important, please. Advanced level learning. In the board level, you will not have this much of in-depth questions, but they may ask you this question as an objective. In the board level also, they may ask you directly as an objective question in the board level also. So that is not 5 pi by 3, but minus pi by 3. Remember that. Remember that. So this is what about the sine inverse of sine x, please. Are you with me, boys and girls?
Yes, sir.
Did I explain it properly or not? Do you understand this or not? Ved,
Yes.
Dhananjay, Jahan. So similarly, if you take cos inverse of cos x, you know what happens when this graph will be shifted totally above x-axis. The reason is here the range of sine inverse x is minus pi by 2 plus pi by 2, but range of cos inverse x will be 0 to pi, and hence the graph totally will be shifted to shifted above x-axis. Let me show you that. Before proceeding to the problems, you must understand all this, otherwise there is no use at all. Where is that? Just a moment, I have that also with me. Cos inverse of cos x also I have drawn. This one. Let us take this direct. Just observe it, every one of you, please. Every one of you, please observe this. What happens in this case? The concept is one and the same. The entire value of cos inverse cos x must lie between 0 and pi. This is the basic thing to be understood first of all. If you understand this, you need not have to even go for the graph. You can adjust the given value between these two. Dhananjay, do you understand what I'm saying? If you remember the graph, that's great. Even if you don't remember also, at least if you remember this value, you know what happens, whatever the value is you need, you make them to be adjusted between 0 and pi and write the value.
Yes, sir.
This is y is equal to x between 0 and pi. Between pi and 2 pi, just to see, it is minus x minus 2 pi. Minus x minus 2 pi. Between 2 pi and 3 pi, it is x minus 2 pi.
सर तो गलत है ना प्लस 2 पाई होना चाहिए माइनस एक्स प्लस 2 पाई
इधर है ना 2 pi minus x.
पाई से 2
हाँ पूरा नेगेटिव हो जाता है ना.
सर प्लस 2 पाई पे मतलब वह एक्सिस को कट करेगा.
You're right. It is plus. It is plus. वो गलत है. तो यार मैं ड्रा किया यार वो नहीं है क्या इधर देखना एक बार. ये तो किसी का मैं ले लिया है. मैं तो ड्रा किया यार. हाँ अरे यार इधर है. ठीक है. ये देखो बेटा. Cos inverse of cos x is that. It becomes x between 0 and pi. It becomes 2 pi minus x between pi and 2 pi. It becomes x minus 2 pi between 2 pi and 3 pi. Just see that. I have showed you that. Okay. Why it happens? Because of the restriction of the domain to the cos x and the restriction in the range of cos inverse x. It must be presented between 0 and pi only. Between 0 and pi only. So, what the problem I have taken there, can you read that in green color? Anyone?
Sine inverse of sine phi plus cos inverse of cos phi is equal.
Don't read that. Now, let us understand sine inverse of sine phi first. If it is given as phi, you may be getting confused. If it is given as phi, it is not degrees, it is phi radians. Its value is approximately 5 into 60. Approximate value, let us take that, 300 degrees. So, cos inverse of cos 300. Cos inverse of cos 300 lies here between pi and 2 pi. Just see that. What is its value between that? Minus x plus 2 pi. Minus x plus 2 pi. So, 2 pi minus x. So, this is cos inverse of cos phi means it becomes 2 pi minus phi. Just see that. Are you there, boys and girls?
Yes.
Now, anyone, do you tell me how to write this sine inverse of sine phi? Sine inverse of sine phi means sine inverse of sine 300. You must make it present between minus 90 plus 90. Minus 90 plus 90. Let us see that. This one. What is it? 300. 300 lies between what? 3 pi by 2 and 5 pi by 2. So between 3 pi by 2 and 5 pi by 2, it is x minus 2 pi, please. X minus 2 pi. Don't forget. X minus 2 pi.
Minus 60.
Huh. So let us move to that. This one. So it is 5 minus 2 pi we wrote. 5 minus 2 pi. It is 5 minus 2 pi. It is 2 pi minus 5. So the answer is 0. You cannot even expect it. Sine inverse sine phi plus cos inverse cos phi. Just remember, please. Just remember. If you don't want to remember this graphical values, but at least you remember the ranges. Not at least, you have to. You have to remember the ranges. If you remember the ranges, you can make the adjustment here. You can make the adjustment here. Okay? So, let me take a problem on this. Just a moment. This is an important thing to be remembered. Now, let us discuss a problem on this one. Oh, yes. Yes. What is this? Yeah, I'm there. See this one? Question, please, boys and girls. cos inverse of cos 12 minus sin inverse of sin 12. First of all, 12 radians, approximately 57 into 12. Or take it as 16, no problem. If you take it as 16, no? 720, no?
Yes, sir.
720 means that becomes an exact value, the terminal value. Tell me what is 57 into 12, 12, 7 is 84, 12, 5 is 60 plus 8, 68. Belongs to, come on, tell me now. Belongs to which range? Which range? It lies in the fourth quadrant, I think. 684, no? 720 minus 4 pi minus pi by 2 is how much? 4 pi minus pi by 2 is how much? 7 pi by 2, na?
Sir, option C are.
ठीक है. 7 pi by 2 is 630. Yes. To 4 pi. First of all, you have to decide this. Okay. So, this is the important point to be noticed first. In which region it is present? 12 radians lies in the range of 7 pi by 2 to 4 pi. Now you have to write the values of this one, cos inverse cos 12. Come on, now tell me, Srivardhan, cos inverse cos 12.
Minus 12 plus 4 pi.
Whatever you do now, generally what should be your observation? It is cos inverse cos 12 must lie between, important point to write them.
Plus 4 pi na, for cos inverse of cos 12.
It must lie between, just a moment, Parsh, 0 to pi. And it must lie between minus pi by 2 to plus pi by 2. These are the points to be remembered first. Come on, now you tell me. Parsh, what is that you're saying now?
Minus x plus 4 pi na, cos inverse of cos 12 के लिए in that interval.
4 pi minus x if you write now. 4 pi minus 12. 4 pi minus 12 means, yeah, that's correct. Correct, no? Srivardhan.
Cos के लिए minus x plus 4 pi और sin के लिए x minus 4 pi.
X minus हाँ वही.
उल्टा यही है ना? अरे आप सब लोग इधर एक बार ध्यान से देखो बेटा. 4 pi is nothing but 720. 720 minus 684. 720 minus 684 means approximately it is 40 degrees. 40 degrees तो इसका रेंज में है, देखो 0 to 180 के बीच में है, तो ये लिख सकते हैं. ऐसा ही ये sin inverse of sin 12, ये 12 minus 4 pi लिखने से क्या होगा देखो एक बार. एडजस्ट करना है बस. Lying between minus 90 plus 90. This is the basic thing to be understood. So pi is 684 and 4 pi is 720. 684 minus 720, it will be minus 40 approximately. Approximate value I'm telling, minus 40. Minus 40 lies between this minus 90 plus 90. So this can be taken. This is to be taken. So cos inverse cos x, 4 pi minus x. Sin inverse sin x, cos inverse cos x. Cos inverse cos x, 4 pi minus x. Sakshi, sin inverse sin x. Sin inverse sin x is x minus 4 pi. Now what is the answer?
Options.
Rachit is there in the class? वेदांत,
यस सर।
संस्कार,
यस सर।
रचित नहीं आया क्लास में?
नहीं सर, रचित नहीं आया।
जो इम्पोर्टेंट डिस्कशन रहेगा तब नहीं आता वो. This is an important concept which is to be understood, particularly in inverse trigonometric function space. I hope you understand this. Every one of you, please respond.
Yes sir.
That's done. That's done. Okay. This concept I'd like to explain to you clearly. I think it is clear. Now, let us shift to the theory part of it. So that's what I explained with more details. And in case of sine inverse x, there is no problem at all, बेटा. देखो एक बार, sine inverse of sine x है. Sine inverse of sine x के लिए x डायरेक्टली लिख सकते हैं अगर x minus 1 to plus 1 है, क्योंकि साइन का वैल्यू कभी देखो माइनस और प्लस 1 के बीच में रहेगा. ठीक है, इधर उतना प्रॉब्लम नहीं आएगा, ये केस में नहीं आएगा. अगर बाहर इनवर्स है तो प्रॉब्लम आएगा, बाहर इनवर्स है तो प्रॉब्लम आएगा, क्योंकि रेंज डिफाइंड है उधर. और tan ऑफ tan इनवर्स x है तो x आएगा, ये प्रॉब्लम नहीं है. लेकिन इधर सेट ऑफ रियल नंबर्स है तो प्रॉब्लम नहीं है, इधर भी सेट ऑफ रियल नंबर्स से प्रॉब्लम नहीं है, ज्यादा प्रॉब्लम उधर नहीं रहेगा. एंड very importantly, what I'd like to tell you, sine inverse of minus x is minus sine inverse x, and cos inverse of minus x is pi minus cos inverse x, tan inverse of minus x is minus tan inverse x, and cot inverse of minus x is pi minus cot inverse x, secant inverse of minus x is pi minus secant inverse x, cosecant inverse of minus x is cosecant inverse minus x. I'll give you very clear picture about that. Not to by heart. What I mean to say, not to by heart, is like this. See, beta. Now let me check. Tell me the range of sine inverse x, Dhananjay. Tell me the range of sine inverse x, beta.
So minus 1 to 1.
अरे रेंज बेटा, रेंज थोड़ा कंफ्यूजन रहेगा उधर. रेंज माइनस 90 टू प्लस 90 प्लस 5/2. और पार्श cos इनवर्स x का बताओ बेटा. हाँ, 0 to pi. मतलब आप देख सकते हैं साइन इनवर्स x का नेगेटिव भी है, पॉजिटिव भी है, लेकिन cos इनवर्स x का सिर्फ पॉजिटिव है 0 to pi. डोंट फॉरगेट दैट. tan इनवर्स का नेगेटिव है, पॉजिटिव है, और cot इनवर्स x का सिर्फ पॉजिटिव है. secant इनवर्स का सिर्फ पॉजिटिव है, कोसेकेंट इनवर्स का बोथ नेगेटिव और पॉजिटिव है. जहां नेगेटिव रहेगा वहां माइनस बाहर डायरेक्टली आ जाएगा बेटा. जहां रेंज में नेगेटिव रहेगा वहां माइनस डायरेक्टली बाहर आ जाएगा. दिस इज व्हाट आई मीन टू से. जहां रेंज में नेगेटिव वैल्यू नहीं है, इसलिए आपको आएगा ये पाई माइनस आएगा, क्योंकि ये 0 to pi है इसका. आप ऐसा याद रख सकते हैं. समझा कि नहीं मैं जो बोल रहा हूं, समझा कि नहीं आप लोग?
यस सर.
हाँ सर समझ.
ये देखो, ये पाई है, ये पाई है. क्यों आया बेटा पाई इधर? क्योंकि ये तीनों का रेंज 0 to pi के बीच में रहेगा बेटा. ये तीनों का रेंज 0 to pi के बीच में रहेगा, लेकिन बाकी तीनों का तो नेगेटिव वैल्यूज भी रहेगा, इसलिए माइनस डायरेक्टली बाहर आ जाता है. माइनस डायरेक्टली बाहर आ जाता है. That's what you have to remember. Okay. कोई कॉल किया क्या? रचित तुरंत आ गया क्लास में.
नो सर, थोड़ा क्रैक हो रहा था, इसीलिए मैं लीव करके फिर से ज्वाइन किया.
तो शुरुआत से था क्लास में?
हाँ सर.
Sin inverse x plus cos inverse x equal to pi/2. X belongs to minus 1 to plus 1. Very important concept to be remembered. And secant inverse x plus cosecant inverse x equal to pi/2, where x belongs to minus ∞ to minus 1, union 1 to infinity. मैं इधर आपसे एक रेंज का प्रॉब्लम डिस्कस करना चाहता हूं, जो प्रीवियस आईआईटी क्वेश्चन है. ये इसके बेस पे, इस ए कॉन्सेप्ट के बेस पे. ठीक है ना? देखो एक बार, मैं क्या बोल रहा था, एक ऐसा है क्वेश्चन आया था, फाइंड द रेंज ऑफ ऐसा दिया बेटा, तो बच्चों ने उस समय क्या किया था वो भी बताऊंगा मैं। बच्चों ने उस समय क्या किया था, ऐसा लिख के आ गया, ये तो π/2 सबको पता है, वो लिख दिया। tan इनवर्स x का आपको पता है, ये माइनस रेंज क्या है tan इनवर्स x का,
-π/2 to π/2
हाँ।
interval।
तो दोनों का ऐड कर दिया, 0 to π लिख के आ गया।
π/4 to 3π/4।
हाँ, π/2 माइनस π/2 0 हो गया, और π/2 प्लस π/2 पाई हो गया, 0 पाई लिख के आ गया, तो वो गलत जाएगा। क्यों पता है? There is a problem, major problem in inverse trigonometric functions is that you have to remember all the restrictions. To remember those restrictions, you must have the clear idea of domains and ranges. So I will be writing this as π/2 plus tan inverse x, and you should not forget that when x belongs to -1 comma +1.
Yes, sir.
ये बच्चे भूल जाते हैं, जनरली स्टूडेंट्स।
-π/4 से π/4 लेंगे।
तो अभी क्या होगा, ये π/2 lower value -1, because tan inverse x is an increasing function. We take them as it is, lower for lower and upper for upper. This is the thing to be remembered. So इसका रेंज क्या हो जाएगा बेटा, ये 3π/4 LCM 2π minus π. π/4 comma 4 LCM 3π/4. ये बताया क्या, कौन वेद ने बताया है आंसर, और अलग बताया? हाँ बेटा। So what is the important thing to be noticed, where the students generally go wrong, is this: it becomes π/2, no doubt, but it is very much linked up with this one. You should not forget this. So this is the range, please. This is the range. That's it, beta. I hope you understand that, everyone. So don't remember simply the formula as it is, but remember the formula with the restrictions. Remember the formula with the restrictions, please. Okay. Now, most importantly, conversion of inverse trigonometric function to other inverse trigonometric functions. If you understand this, almost 60 to 70% problems can be solved very easily. What is that I mean to say? Just listen. For example, but before that itself, I am writing under defined domains and ranges. But in solving the problems of inverse trigonometric functions, you must keep this in mind. It is no way different from trigonometry, except that domains and ranges will be changed. Sine inverse x by y है बेटा, इसको मैं cos inverse में कन्वर्ट करना चाहता हूं, तो आपको इधर निकलेगा, क्या निकलेगा? ऑपोजिट साइड्स और हाइपोटेन्यूज यूज करके हम एडजेसेंट साइड मालूम करते हैं.
minus x square divided by y.
अब क्यों नहीं आया? आंसर नहीं दिया यार, इतने दिन क्यों नहीं आया था?
सर रिवाइज नहीं किया था फाइनल.
मैं क्या पूछ रहा हूं, आप क्या बता रहे हैं यार? मैं क्या पूछा?
क्यों नहीं आया?
कितने दिन से?
2 दिन.
नहीं नहीं यार. So tan inverse opposite side by adjacent. So don't think that inverse is different, inverse trigonometry is different and trigonometry is different. No, we use the same concepts. Similarly, while writing the reciprocals, just reverse the terms inside, root over y square minus x square by x. This is done, and this is cos inverse secant inverse x by root over y square minus x square, and similarly cosecant inverse y by x. But all these are under, this is important thing to be remembered. Sometimes it changes. So you have to keep this in mind. Which one? Under the defined domains and ranges. This is the important thing to be remembered. Okay. So whatever the inverse function is there, whatever the inverse trigonometric function is there, it can be comfortably converted to the remaining 5 inverse trigonometric functions. If you know this, the problems goes very easy for you. So you be clear about this first. Be clear, be more clear about this. Any inverse trigonometric function can be converted to rest of the 5 inverse trigonometric functions. Rest of the 5 inverse trigonometric functions. That's it, please. ठीक है? That's done.
cos inverse x में डिनोमिनेटर में y आएगा.
You're right, beta. You're right. ठीक है. Now let us move on to the next part of it. That's what he has shown here. You understand that? Sine inverse x is converted to the rest of the 5. Cos inverse x is converted to the rest of the 5. Tan inverse x is converted to the rest of the 5. This you have to understand. But there are some restrictions there because of the restricted domain in defining the inverse. Sine inverse 1 by x can be just visualize and remember. Visualize and remember. Sine inverse 1 by x is equal to cosecant inverse x for all x belongs to minus infinity to 1 to 1 to infinity. Okay. So similarly, cos inverse 1 by x can be written as secant inverse x provided x belongs to minus infinity to plus infinity, but not lying between minus 1 plus 1. This is minus is missing here. Minus is missing here. Minus 1 plus 1. You must have minus here. There is minus. Similarly, here also for tan inverse 1 by x, this is also important. If x is positive, no doubt you can straight away write the inverse. If x is positive, you can straight away write the inverse as cot inverse x. But if x is negative, you have to adjust it. You have to adjust it between minus pi and cot inverse minus pi plus cot inverse x. What happens now? What is the range of cot inverse x? Anyone in the class? What is the range of cot inverse x? 0 to pi.
Pi.
0 to pi. So if you write 0 to pi here, again it will be adjusted between minus pi by 2 plus pi by 2. So remember this please. Tan inverse 1 by x is minus pi plus cot inverse x. Tan inverse 1 by x is minus pi plus cot inverse x. Please remember. Okay. These are all the problems we'll be working out. No problem in this one. We'll be doing all this. And you might have done in your main level all these problems. Did you? I asked you a question, please.
Yes, sir.
And here also, there is a little modification. What I'm saying, trigo to inverse trigo. I'll discuss that. Just a moment. Trigo to inverse trigo. Not to by heart the formulae of inverse trigonometric functions, provided you know the formula of trigonometry, how they can be converted and seen in the inverse trigonometric function. That's what I'm discussing. For example, you have tan of a plus tan a plus tan b upon 1 minus tan a tan. Now, this is to be converted to,
Take tan inverse on both sides.
yeah, to inverse trigo. Then, simple thing to be understood, you replace a with tan inverse x and b with tan inverse y.
So tan inverse of x plus y is x plus y upon 1 minus xy.
Bring this tan to other side, that becomes tan inverse x. Bring this tan to other side, that becomes tan inverse. Now, what is that I took? I took x, a is equal to tan inverse x means x is equal to tan a. X is equal to tan a, y is equal to tan b. X is equal to tan a, y is equal to tan b. This becomes x plus y divided by 1 minus xy. This is what to be understood. Very, very importantly, under defined domains and ranges. This plays a major role in inverse trigonometric functions. So that is how you can convert any trigonometric formula to inverse trigonometric formula. Like what? I'll take sine 3a. 3 sine a minus 4 sine cube a. This is to be converted to inverse. This is to be converted to inverse. Simple thing is that you replace a with sine inverse x. I repeat. You replace a with sine inverse x. Three as it is. If I replace a with sine inverse x, what is x? Sine a. If I replace a with sine inverse x, what is x? Sine a. So bring this sine to other side, which becomes sine inverse of sine a x, sine cube a x cube. That's it. This is converted. Like this, any trigonometric formula can be converted to inverse trigonometry like this. If you understand this, the entire inverse trigonometric functions goes very, very easy for you. Very, very easy for you. So just to transform all the trigonometric formulae to inverse trigonometric formulae like this. Transform all the trigonometric formulae to inverse trigonometric formulae like this. Okay? Now, let us move on to the next part of it and we'll be working out the problems also. But the restriction here is that there are some restrictions because of its defined domain and range. And xy less than 1, then you can straight away write this. This is the point to be remembered in this case. Both x and y are positive and xy less than 1. Just see that, please. See that what I'm saying? Similarly, tan inverse x plus tan inverse y, you will get pi plus tan inverse of x plus y by 1 minus xy. Very important, very, very important. You have good number of previous questions on this one. Tan inverse x plus tan inverse y is equal to pi plus tan inverse of x plus y by 1 minus xy. There are derivations for this. And one more thing, simple question, why it happens? You tell me why it happens. Why?
x y greater than 1 हो गया तो नेगेटिव हो जाएगा tan inverse का term.
That's okay. But simply, broadly saying, it happens because of restricted domain of the trigonometric function. Restricted range of the inverse trigonometric function. It happens because the inverse value, whatever you write, it must lie between a particular value in the range. That is why you'll get pi plus for xy greater than 1 and minus pi plus for xy less than 1. Xy, this is x and y both are negative. X and y both are negative, xy greater than 1. X and y both are positive, xy greater than 1. So, these are the things to be remembered, please, in writing the application of the trigonometric formulae into the inverse trigonometric formulae. Conversion otherwise, a transformation of trigonometric formulae to inverse trigonometric formulae. It goes like this. Okay, next. This is tan of a plus b plus c formula. I need not have to tell you that. Similarly, cot of a plus b formula. And this also frequently comes sine inverse x plus sine inverse y. Sine inverse x plus sine inverse y is equal to sine inverse of x root 1 minus y square plus y root 1 minus x square is nothing but sine a cos b plus cos a sine b. Sine a cos b plus cos a sine b. It's nothing but that. Similarly, you can see even cos inverse x plus cos inverse y is equal to cos inverse of xy root over 1 minus x square into root over 1 minus y square. If you understand that conversion from trigonometry to inverse trigonometry, these are the formulae need not to be by hearted because you know all the trigonometric formulae. Only thing here you have to understand or you have to remember the restrictions imposed here. The restrictions imposed here. Okay. That's it. And now this one we will be discussing in the problems. No problem at all. And any more formula left over? Let me revise once. This one. This is multiple and submultiple angles. Multiple and submultiple angles. Just see this. Sine 2a formula, 2 sine a cos a. See how this minus pi by 2 to plus pi by 2 restricted here. It is restricted between minus pi by 4 plus pi by 4 because you have 2 here, 2 here. If you have 2 now, 2 into minus pi by 2, minus pi by 4. 2 into pi by 2 plus pi by 4. That is sine inverse x value, minus 1 by root 2 to plus 1 by root 2. This is the point to be remembered. And just now I wrote this 3 sine inverse x formula. 3 sine inverse x formula, this one. First of all, remember the main formula. After that, restrictions can be remembered. 3 sine inverse x formula.
सब तो कभी डिराइव ही करना पड़ेगा ना, इसमें कैसे याद रखेंगे रिस्ट्रिक्शंस वगैरह?
restrictions उतना समझ जाएंगे आप लोग, ऐसा नहीं है. वो बेसिक रेस्ट्रिक्शन आपको याद है तो थोड़ा ध्यान रहेगा आपका, वो तो थोड़ा ऑल्ट्रेशन है बोल के. सो बेसिक रेस्ट्रिक्शन तो याद रहेगा, उसकी वजह से आप ऑल्टर कर सकते. सिमिलरली 3 cos inverse x, cos inverse 4x cube minus 3x. This is frequently used formula 2 tan inverse x is equal to tan inverse of 2x by 1 minus x square. Okay. And this is also to be understood, please. Very important one. 2 tan inverse x is equal to sine inverse of 2x by 1 plus x square. बच्चे generally confuse हो जाते हैं इधर. X is equal to tan theta, 2 tan theta by 1 plus tan square theta. Sine inverse sine 2 theta, 2 theta, so 2 tan inverse x.
Yes, sir.
So this is also an important transformation that is to be remembered. Similarly, not only that, you have the same for cos inverse also. This one. What I'm saying, 2 tan inverse x equal to tan inverse sine inverse 2x by 1 plus x square. And 2 tan inverse x is equal to cos inverse 1 minus x square by 1 plus x square. Okay, both are same, just remember that. Similarly, tan 3a, 3 tan inverse x is equal to tan inverse of 3x minus x cubed by 1 minus 3x square. Okay, you remember that. The rest of them it can be derived. That's all. Multiple and submultiple angles. That's it, please. Let us move on to the problems now.
सर आज अपना इनवर्स ट्रियो खत्म हो जाएगा.
नहीं होगा बेटा, देखना है, थोड़ा बचेगा. एनी प्रॉब्लम? क्या पूछ रहा है?
नहीं सर ऐसे.
आपका एडवांस में क्या बचा है अभी? ये प्रॉपर्टीज तो करेंगे, ये इसमें हो जाएगा प्रॉपर्टीज. और क्या बचा?
शायद से प्रोबेबिलिटी भी हो गया है.
पीएनपी नहीं, एडवांस का नहीं हुआ था.
हो गया था.
आके सब पढ़ाया था ना?
नहीं पढ़ाया था.
बीच में देवेंद्र सर बोल रहे थे कि वो बाकी है इसलिए.
नहीं आरके सर ने तो पढ़ा था.
हाँ वो मुझे याद है, पर बेलन सर बोल रहे थे बाद में और सेशन लेंगे.
But what about the entire geometry?
हाँ सर, ज्योमेट्री में प्रॉपर्टीज ऑफ ट्रायंगल्स है वो सब, बट प्रॉपर्टीज ऑफ ट्रायंगल्स वीके सर ने करवाया है. हाँ कॉम्प्लेक्स नंबर्स भी है.
मतलब मेन लेवल पे किया था.
हाँ
हाँ मेन
और स्ट्रेट लाइन और वो सब तो आपने करवा दिया था. स्ट्रेट लाइंस, पेयर ऑफ स्ट्रेट लाइंस,
पेयर ऑफ स्ट्रेट लाइंस नहीं कराया था.
पेयर ऑफ स्ट्रेट लाइंस बाकी है. 3D ज्योमेट्री हो गया था, आपने 3D ज्योमेट्री भी करवा दिया था. पेयर ऑफ स्ट्रेट लाइंस बाकी है, कॉम्प्लेक्स नंबर्स बाकी है, प्रॉपर्टीज ऑफ ट्रायंगल्स बाकी है,
और बस ना पीडी.
हाँ वो स्टैटिस्टिक्स.
और स्टैटिस्टिक्स एडवांस में नहीं है बेटा.
नहीं है, एडवांस में नहीं है स्टैटिस्टिक्स.
स्टैटिस्टिक्स एडवांस में नहीं. प्रॉपर्टीज ऑफ ट्रायंगल्स अभी हो जाता है, कुछ प्रॉब्लम नहीं.
हाँ
तो क्या बचा?
कॉम्प्लेक्स नंबर्स और प्रॉपर्टीज ऑफ ट्रायंगल्स, बस और कुछ नहीं.
पेयर ऑफ स्ट्रेट लाइंस.
पेयर ऑफ स्ट्रेट लाइंस एडवांस में नहीं है. और बाकी ज्योमेट्री है ना पूरा का, कोनिक सेक्शंस का.
हाँ कोनिक्स तो आपका चालू है ना सर.
वो मेन लेवल पे चालू है.
हाँ उसके बाद मेंस पे खत्म होगा तो एडवांस है. मेंस के लिए सब लोग हैं.
क्या बेटा मेंस लेवल पे?
मेंस लेवल तक सब लोग है, मतलब नॉन एटीपी एटीपी दोनों मेंस तक.
तो एडवांस पे वो करना पड़ेगा, है ना?
हाँ सर.
So now if you see this problem, the number of solutions of the equation x belongs to open 0 comma 1 implies x by 1 minus x square and 1 by x cube greater than 0 and x by 1 minus x square into 1 by x cube, because x is lying between 0 and 1,
greater than 0.
greater than 0. This is a point to be noticed. If you do not notice this, the entire problem goes wrong. Now, if you write this, tan inverse if you write this, it is tan inverse x plus tan inverse y formula. Tan inverse of, anyone do tell me the simplified form of it? But you must write pi plus, no? You must write pi plus. I'll write that at the end. I'll write that at the end. Tan inverse of x plus y, that is
तो मल्टीप्लिकेशन लेस देन 1 भी है ना.
हाँ
लेस देन 1 भी है तो हम डायरेक्ट ही फार्मूला लगा सकते हैं.
x
एक मिनट भाई, इधर ग्रेटर देन 0 लिखा है. एक मिनट बेटा, एक मिनट. ग्रेटर देन 1 लिखना है.
सर लेस देन 1 है ना. पर
हाँ वही सर, x भी लेस देन 1.
नहीं
तो
यार,
x
x तो लेस देन 1 है यार. एक मिनट, ये दोनों पॉजिटिव लग गया. x ग्रेटर देन 0, y ग्रेटर देन 0. इसका प्रोडक्ट देखो ना, प्रोडक्ट ग्रेटर देन 1 हो जाता है. फॉर एग्जांपल, इफ यू टेक 1/2 here, substitute 1/2 here, what happens? You will get more than 1. समझा कि नहीं?
हाँ यस सर. यस.
So tan inverse of, apply the formula x plus y by 1 minus xy. So x power 4 plus 1 divided by, cross multiply कर रहा हूँ, x power 4 plus 1 minus x square divided by x cube into 1 minus x square. I'm writing directly the formula simplification. Which formula? Tan inverse of x plus y by 1 minus x. plus pi is equal to 3 pi by 4. This is what the equation given in the simplified form. So आप बताओ इधर क्या बचेगा बेटा?
तो अभी पाई को उस तरफ शिफ्ट कर देंगे तो माइनस पाई बाय 4 रहेगा एंड तो दोनों तरफ tan ले लेंगे हम लोग. So tan of minus pi by 4 is -1. So x raised to 4 plus 1 minus x square is minus x cube plus x raised to 5 minus x plus x.
X power 4 minus x square
Plus 1.
whole divided by इधर आपको
x cube खोलना पड़ेगा.
x कॉमन ले सकते हैं क्या? देखो एक बार माइनस x कॉमन ले लिया फॉर एग्जांपल.
उधर न्यूमरेटर में x नहीं ले सकना कॉमन की.
x पावर 4 आएगा माइनस x कॉमन लेने से. ये माइनस x क्यूब में माइनस x स्क्वायर आएगा और प्लस 1 आएगा डिनोमिनेटर. समझ रहा है क्या लिखा मैं? This is 3 pi by 4 minus pi means it is minus pi by 4. It is tan of minus pi by 4 minus 1.
-1.
So these two you can see getting cancelled.
0 आ जाता है. ये 1 by x 1 आ जाता है and x should lie between 0 to 1. तो and 1 पे भी राउंड ब्रैकेट है तो 0 आ जाएगा आंसर. नंबर ऑफ सॉल्यूशंस
X equal to 1 we got does not belong to open 0 comma 1 open. Therefore no solution for this. X equal to 1 is a solution but it is not lying between 0 and 1. So number of solutions he's asking for is 0 number of solutions are there. 0 number of solutions. Okay. Next. Do you understand this, every one of you?
Yes, sir.
yes sir.
Number of common points for the curve sine inverse 2x plus tan inverse of 1 by integral part of 2x plus 2 and y is equal to cos inverse of 2x plus 5 plus 1 is number of common points for the curve. Common points means points of intersection. Common points exist only when there is common domain. So let us check the common domain. If common domain is not existing, you can say straight away, no common points. Let us check for it. If you see sine inverse 2x here now, what is the domain of sine inverse x, please?
-1 to
Minus
the
1
close bracket.
First curve.
-half to half हो जाएगा.
You're right. Keep it like this. But for this one, the domain is set of real numbers. So you have to take the common value. Common value for tan inverse, sine inverse will be sine inverse domain only. Are you with me what I'm saying? What is the domain of, I repeat this, what is the domain of sine inverse x, please? -1 to +1. What is the domain of tan inverse x, please?
Real.
Real numbers. So common value of both is sine inverse x only.
मतलब अंदर कुछ भी रहा उससे फर्क नहीं पड़ेगा, आर ही होगा.
ठीक है? So for the first curve, that is the domain, and second curve.
So second वाले के cos inverse of 2x plus 5 का
हाँ, इसे lie between -1 and 1 वैसा देखना पड़ेगा.
अरे बट cos inverse तेरा ये देगा ना माइनस ये 0 से पाई तक वैल्यू देगा cos inverse.
हाँ.
तो 1 और पाई प्लस 1 के बीच में लाई करेगा.
-2
हो गया? देखो अब. No common domain. मतलब पॉइंट ऑफ इंटरसेक्शन होने के लिए अगर कॉमन डोमेन नहीं है तो कर्व्स दो इंटरसेक्ट ही नहीं होगा. Implies no points of intersection. ठीक है? So what should be your answer?
A.
0.
क्वेश्चन तो सिंपल है, लेकिन डिस्कशन तो ये थोड़ा आपका, ये सब आप देख सकते हैं इनवर्स ट्रिग्नोमेट्री में. इसका डिस्कशन आपको ज्यादातर डोमेन्स एंड रेंजेस पे रहेगा. अगर क्वेश्चन को ट्विस्ट करना है बोर्ड लेवल पे इतना नहीं रहेगा बेटा. बोर्ड लेवल पे आपको डायरेक्ट क्वेश्चंस निकल जाएगा, लेकिन ऑब्जेक्टिव्स में you must have the clear idea. You must have the clear idea.
Yes.
That's it. Zero less than x less than 1, the number of solutions of the equation. Tan inverse x minus 1 plus tan inverse x. आप ये दोनों को अलग कर दो.
So we know the formula for tan of a plus b plus c.
You can do that बेटा, लेकिन लंबा हो जाता है यार.
हाँ.
बहुत लंबा हो जाता है ना, प्रोडक्ट में है लंबा हो जाता है. You can do that. इसलिए हमने इसको छोटा कर दिया. अभी मैं क्या कर रहा हूँ, दोनों तरफ tan इनवर्स आएगा, तो इसलिए वो tan इनवर्स भी नहीं लिखूंगा, तो मैं लिख रहा हूँ tan इनवर्स x plus tan इनवर्स by tan इनवर्स of x plus y by 1 minus xy. x plus y by 1 minus xy मतलब ये दोनों को ऐड करने से 2x minus 1 आएगा.
Minus 1 upon x square minus x plus 1.
1 minus
1
xy.
minus x square plus x है.
1 minus.
लेफ्ट हैंड साइड पे x and y दोनों greater than 0 जरूरी नहीं है. x minus 1 can go below also ना.
Because we are solving it now. Finally, you have to check with this one. Finally, we solve it as it is, but finally we will check with this one.
अभी तो तू x को कुछ दे ही नहीं रहा ना डोमेन में, तो ऐसे ही ले रहा है.
Solve कर. तो 1 minus x square minus x. Directly लिख दिया यार. 3x minus x minus 1. 2x minus 1. Whole divided by 1 plus 3x square plus 3x. Tan inverse of x minus y by 1 plus xy लिखा है. Two x minus 1, don't cancel it off. Don't cancel it off. Generally, we are habituated to cancel like that. Trying from the lower classes like that. Trying from the lower classes like whatever is seen common, we used to cancel it. Don't do that. Take it common because we are solving an equation. If you cancel it like that, you are losing a solution. Don't forget.
X is equal to solution होगा ये.
Hmm.
But it's not in between 0 and 1 open.
So what is that you get now? We have taken it common and minus and 1 plus 3x square plus 3x minus 1.
तीन सॉल्यूशंस हो गए.
नहीं एक ही होगा क्योंकि 0 से 1 के बीच में
हाँ
है.
हाँ यार राइट एक ही होगा.
Now in the cross multiplication we cancel these terms in the denominator, and you must ask me immediately the question that, sir, can we cancel them like that in the cross multiplication? Yes, you can do, because it will have all positive roots. Just check it out. B square minus 4ac, if you check it for this, b square minus 4ac is less than 0 for this and for this, and hence it will always have positive roots, and hence no zero possible. No zero possible. It is always positive and it is always negative. It is always positive, it is always negative. That is why I cross multiplied them and cancelled. Now you will get it is equal to 0, which implies that x is equal to 1 by 2.
बस वही एक सॉल्यूशन है.
हाँ
बाकी
डोमेन
क्या हो रहा है इधर?
इधर एक x is equal to 0 आता है और
इक्वल टू -1 भी आता है, पर वो दोनों A1 इंटरवल में.
अच्छा, और -1 ना?
हाँ सर.
So this is only the solution you will have because it lies in the interval. अभी समझ गया ना कौन है वो पार्श? अभी हमने ऐसा ही सॉल्व किया, पूरा वैल्यूज आएगा लेकिन जो वैल्यू हमको चाहिए वही ले लेंगे.
सर और मैंने tan inverse of a plus b plus c के उससे भी सॉल्व किया, तो मोस्ट ऑफ तो कट ही हो जाता है x plus 1 और x minus 1.
वेरी गुड बेटा, हो गया तो वेरी नाइस. अदरवाइज इट इज द बेटर मेथड व्हाट आई सजेस्ट. ओके पार्श, अभी हमने सॉल्व किया, x का अलग अलग वैल्यूज आ गया, इसलिए लास्ट में चेक कर दिया. अभी समझ गया ना आपने?
समझा सर, समझा.
हाँ, शुरुआत में क्वेश्चन पूछा. दैट्स व्हाट इट इज. We will continue in the next session, please. See you all in the next session. Bye bye.
Thank you.
थैंक यू सर.